Welcome back. Today we discuss ambiguity and uncertainty. As an engineer, you will rarely have all the information you need prior to making decisions. You're often working with incomplete data, ambiguous client requirements, and real-world constraints. Yet, your ability to move forward with confidence, justify your reasoning, and mitigate risks will set you apart in the consulting world. Today we jump into the strategies that will help you get there. We will discuss how uncertainty is unavoidable, how structured frameworks work, and how to communicate your clarifications. To know what we should mitigate against is a crucial part of any strategy. While you were studying, the problems you were given often only had one correct answer, or at most two possible methods to complete. But in industry, the problems are very often open-ended. Clients may not know exactly what they need. The data you're supplied with may be incomplete. Your job is to move forward with the best decision possible, despite these uncertainties. The best way forward in your work is to accept ambiguity as your new best friend. Work with how malleable a situation is that is uncertain, and make the process of clarifying the problem and solution something you enjoy doing. The first thing is to clarify what you don't know, and what you assume. Then, you need to find a way to find out what you don't know, and see if your assumptions are correct. Previously, a memo or example was your friend. Now what do? You use structured decision-making frameworks or structured frameworks for reasoning to guide you to the answer that is close enough to correct. These frameworks are methods that you can use to structure your thinking. When you're faced with ambiguity and uncertainty, it's easy to get lost. To find ourselves, we start here and apply the frameworks that are most appropriate to the task at hand. The first framework is first principles thinking. You break the problem up into the fundamental principles that govern the problem. You'll quickly find the parameters you need to set in order to solve the problem. Inlet-outlet conditions in a flow problem, loading and movement constraints in a design problem, etc. The second framework is a trade-off analysis. You compare competing options based on cost, performance, and risk, and select the options that best suits the client's needs. The second framework is a trade-off analysis. You compare competing options based on cost, performance, and risk, and select the option that best suits the client's needs. The third framework is a probabilistic approach. You assign a likelihood of occurrence to each outcome. You determine the impact of the outcome happening and perform a statistical risk analysis to determine which option would be least detrimental to in its outcome. You can think of a manufacturing process where 1 in every 10 products will have an irreparable flaw, versus the manufacturing process that takes 30 minutes longer per product but has minor flaws in 1 in 100 products. The fourth framework is mapping out decision trees, thinking through the consequences of the decisions you make to be able to better determine which decisions have higher impact and which decisions do not affect the outcome so much. This would be great in determining the following framework, the 80-20 principle, focusing on 20% of the data that drives 80% of the project outcome. If you can identify which information is most crucial to have and which information can be assumed or approximated, you have added value to the analysis and applied your engineering skill well. Ultimately, having and using decision frameworks reduce your uncertainty and clarifies your problem. Choosing the right framework for the problem is crucial to solving for uncertainty effectively. It's very important that these exercises are always documented well to indicate your assumptions and reasoning. You will definitely refer back to them. You will refer to your decision framework documentation when you communicate your reasoning to the stakeholders of the project. As a junior, you will communicate your decisions to your technical lead for quality assurance. They will guide you through any errors or uncertainties that may be lurking. They might suggest additional frameworks that I have not mentioned. But going to them with a structured decision-making framework really supports their guidance of you. They can see where you are because you know where you are. You might be able to frame questions better. Communicating your work to your technical lead is so much clearer with decision-making frameworks to support it. You will have to communicate with your client how you come to the solution you got using these decisions frameworks. This should most ideally be done throughout the project, especially if assumptions are made and need to be signed off. But this communication with the client actually fuels buy-in. They can trust your engineering thought process because it is structured, logical, endeavors to provide clarity. This is good for business. When you clearly document your assumptions, limitations, risk mitigation, you communicate structured reasoning. This builds trust, no matter your audience. And if you have a structured reasoning, you focus on next actionable steps despite uncertainty. And it's here that complex problems can be solved successfully. All right, now you get to apply these concepts in real-world engineering decisions. This worksheet walks you through key decision-making frameworks and helps you to practice structuring decisions in a consulting context. You can use it in your next ambiguous project. In the activity, you'll create an engineering proposal with missing data, just like in real consulting work. By doing this, you'll build confidence in making structured, rational decisions, even when faced with uncertainty. Great engineers aren't the ones who avoid ambiguity. They're the ones who know how to navigate it. Go and apply these skills.